All right, so on today's notes, like I said, like these problems, we've done that before. We already know how to factor this kind of stuff, but we're not going to go over that. We're going to skip ahead a little bit to this difference of two squares. And what I'm basically going to show you is a shortcut for factoring if you only have two terms. So if your two terms are set up in such a way so that you've got something squared minus something else squared, then the two factors are always going to be the square root of this number plus the square root of this number, and then the square root of that number minus the square. So in other words, a plus b and a minus b. So let me show an example of how that plays out, and then we'll kind of do some of these together. So let's look at number 9. S squared minus 49. So in order for this to work, both terms have to be perfect squares, okay? And you've got to be subtracting them. So is 49 a square? Like, in other words, yeah, like what's the square root of 49? 7. So 49 is considered a perfect square, okay? So the factors here are going to be s plus 7 and s minus 7. So essentially what you do is you just square root both terms, and then that's literally it. Yeah. So this is a nice little shortcut when you have a difference of two squares. Now, you could solve it the old method, right? Like you could solve it with the big X. Let me just show you all the work that you would have to do to get there. Well, what is the middle term here? Like, if this were a trinomial, what would that middle coefficient need to be? Well, if you had 1x, then we would see it, right? So what would the coefficient have to be if you don't see that middle term? Well, if it was 1s, we would see like plus s. So, but if you don't even see it, then what's the coefficient? 0, right? So in other words, what are two numbers that multiply to give you negative 49, but add up to 0? Well, if they add up to 0, then one's got to be positive and one has to be negative. It would be 7 and negative 7. So you could go through that process, but it's way easier if you just know the rule for factoring a difference of two squares. Number 10. What's the square root of t squared? 9. You gave me the right answer to the wrong question. Yeah, just t. So both of these will be t. One will be plus, one will be minus. And then what's the square root of 81? 9. So these difference of two squares problems should be relatively simple. The hardest thing is recognizing whether or not it's a perfect square. And that brings us to number 11. Yes, sir. So it'll always be like that.
Oh, so no matter what?
No matter what.
Okay.
For these. Now, for number 11, is 54 a perfect square? No, and neither is 6. So, as it stands, we can't really use this trick, right? We would have to go through the factoring by grouping to get our two factors. However, what we can do sometimes, if it looks like it's kind of set up to be a difference of two squares, but these aren't squares, oftentimes you can factor out a GCF first. So you want to be on the lookout for that. What is the GCF there? So yeah, the GCF here is 6. If I factor that out, I get h squared minus what? What's 54 divided by 6? 9. Now is 9 a perfect square? Yeah, so now we can do the difference of two squares factoring technique. Okay, so you're still going to have that 6 kind of hanging out there, but what are the two factors going to be? H, yeah. Look at the previous two problems and see how we did it. What's the square root of 9?
3.
Yeah, so h plus 3 and h minus 3. Good. Okay, let's take a look at number 12. Now, are both of these perfect squares? Yeah. Okay, so what's the square root of 4g squared? 2g. So these are going to be 2g, and what's the square root of 25? 5. So this should be 2g minus 5, or 2g plus 5, 2g minus 5. The order doesn't really matter as long as one of them is plus and one of them is minus. All right. Okay, number 13. Are those two perfect squares? Yeah, and even though x squared is coming after the 16, that's okay. You just sort of stay the course, and we say, okay, well, what is the square root of 16? 4. And what's the square root of x squared? Yeah, just x. Let's try number 14. All right. So are both of these perfect squares? Is 81 a perfect square? Yeah. 49, we already established that's a perfect square. So what is the square root of 81? 9. So it'll be 9 plus something and 9 minus something. Well, we got to find the square root of 49k squared. 7k. That's it. 7k times 7k is 49k squared. How are y'all feeling about this so far?
So the reason why we got 7 is 49 is divisible by 7.
Well, it's the square root of 49.
Oh, the square root.
Yeah. Let's answer this application problem. I feel like these are the problems that are kind of giving y'all issues. So this says polynomial represents the area in square feet of a square playground. Now right away it says it's a square, so what does that tell you about the two sides? Or all the sides? They're equal, right? So the two dimensions, the length and the width, should be the same. So we should just expect that to happen. So as we solve this out, we're going to see if that actually works. It says write a polynomial that represents the side length of the playground. Well, if the area is x squared minus 30x plus 225, first of all, how do you find the area of a rectangle? Length times width, right? So there's going to be two binomials that multiply together to give me this. Those will be the length and the width. Okay, now we've already established those should probably be the same because it's a square. So if we work this out and they're not the same, then we did something wrong. So to find the factors of this polynomial, we go back to what we did on Tuesday, which is the factoring by grouping. So we're going to start with x squared minus 30x plus 225. Okay. So this would be like a problem you had on your quiz, right? You're going to drop down the first term and the last term. And we need to split up that middle term. So how do we split up this middle term? Yeah, big X thing. So we got 225, negative 30. Now those numbers are pretty big, so I'm going to, you could think about it for a little bit and get them, or you could take advantage of the calculator here. Okay, so let me zoom in. I already still have that second equation set up, so I don't need to mess with that. But for that first equation, I'm going to take that number that's going to be the product of the two middle terms, in which case it's 225. And so what number divided by x, what number am I going to be looking for in that third column? Negative 30. So I'm going to go to the table. I'm going to try to find that. Looks like I'm pretty close already. And there we go. Oh, look at that. Yeah, and since your shape is a square, you should expect these to be the same. Okay, so negative 15, negative 15. So that'll be minus 15x, minus 15x. Then we're going to group the first two terms and the last two terms. What's the GCF of the first group? X. Good, so we have x, and when we want to divide that out, we get x minus 15. What's the GCF of the second group? 15. And if I factor that out, negative x plus 15. So how can I fix that? Yeah, I really, instead of factoring out a 15, what should I have factored out? Yeah, minus 15. So this will become plus, and this will become minus. And this is where we stop and make sure we're doing things correctly, which it looks like we are. Okay, these two parentheses are the same. They match up. So that's going to be one of your factors. And then what's the other factor? X minus 15. Notice that those two are the same. That's what we were expecting, right? Because the two dimensions are making up a square. So each side length is x minus 15. How do we find perimeter of a shape like this, or just any shape? You add up all the sides, right? So it says write an expression for the perimeter of the playground. You're just going to add up how many of these x minus 15s? 4 of them, right? So let's just add them up. Well, how many total x's do we have? 4. Okay, so 4x, and then we're adding up 4 negative 15s. So minus 60. So that is the perimeter. Any questions so far? Let's do another one. Number 16. The area of a square can be represented by x squared plus 6x plus 9. So once again, it's a square. So we should expect the two dimensions to be the same. That'll be how we know we're doing it right. So let's go ahead and factor it out. We've got x squared, and then we've got plus 9 on the end, and we need to figure out how to split up this middle term. Again, we know it's a square, so those terms should be the same. We're trying to multiply to get 6 and add up, multiply to get 9 and add up to 6. These numbers are pretty small, so it might not really be worth going to the calculator to figure it out.
3 and 3.
Yeah, it's just 3 and 3. So plus 3x plus 3x. What's the GCF of the first group? Okay, so x times x plus 3. And what's the GCF of the second group?
3.
Okay, so plus 3. And it looks like we are going to get the same factors in both cases. So my factors are x plus 3 times x plus 3. Okay, so let's go back and actually answer the question. I don't think we really answered. It said, write an expression that represents the length of a side of the square. So what is the length, the side length of the card?
X plus 3.
Yeah, just x plus 3. Part B says, what's the perimeter when x equals 3? Well, if x equals 3, what's the length of the side? 6. Okay, so when x is 3, x plus 3 equals 6. Right, so that's the length of the side. And if there are 4 sides, 6 plus 6 plus 6 plus 6,
24.
get 24.